welcome to the second optimization session for today. For everyone who still doesn't know me, I am HOnza Koudelka from 2ForYou Software. Today I'm going to tell you how I actually got mad about optimizations and how I can help you to optimize your FileMaker solutions to run faster. From the background, I actually started fighting speed issues with our own company information system, that's the abbreviation CIS, in 2007 when we grew to more people that our system could handle without any delays. And since then I tried many different things, including upgrading server hardware, upgrading all machines of all users, upgrading to new versions of FileMaker which were faster, upgrading network from 100 megabits to 1 gigabit in the company, and everything helped a little bit, but the speed improvements were between 10 and 50% every time we did try something. So I started thinking about different ways how to reach better speeds, because I saw at FileMaker DevCons that other developers have solutions that work with millions of records, that have hundreds of users, and they were not slow. So this kept me thinking that there must be a way how to speed up our own system and how to get more from FileMaker. And after trying different approaches, we finally found a way how to speed one specific script up in a way that blew our minds, because we didn't make it 100% faster, we didn't make it 10 times faster. The script ran 311,000% faster. And my first reaction to that was, because the optimization was done by my colleague who we just consulted the different ways how to optimize it, but when I saw the result, I couldn't believe that the script is right. So I spent half a day verifying that the script result returns still the same results that the not optimized script returned, because I thought there must be a bug in the script which is causing it to run so fast. But it worked. It worked fine. It returned exactly the same results, but much faster. And when spending this half day, I actually unveiled the marvelous optimization formula, how I call it, which I will shortly introduce you to. And based on that formula, after thinking and remembering what I learned in a company where I worked before, which was a manufacturing company, I came up with a 4-step optimization process that until now I believe is the most efficient way how to optimize anything. Not just FileMaker scripts, not just FileMaker solutions, but I applied it in real life as well, and it worked the same way. Based on the 4-step optimization process, we built a new product because there was no product available for FileMaker developers to handle this optimization. We built a 2ForYou FM bench, which is a product that is built to support this process, and launched it to the market. And after over a year now, I can say that most people still keep failing. And this finding is the most significant thing that's making me mad about optimizations. but I also discovered why most people keep failing, and this is something I'm going to tell you at the end of this session, and I hope this will help us all change things and grow the group of people who are succeeding with optimizations. So let's start with the marvelous optimization I told you about, and that was inventory reporting script. Just like every company that sells goods, we also sell goods. We sell computer hardware, computers, peripherals, and this involves inventory reporting for accounting purposes. We have to run a report regularly which tells us what goods were on stock on the first day of the month in the midnight, and the report has to be accurate, but we cannot run it in the midnight, we cannot run it the next day, because there are still some transactions that we have to put into the system afterwards. For example, we get goods from the supplier on the last day of the month, but we don't receive the invoice from the customer the next 10 days. So it takes sometimes a week or two to collect all the data to be able to actually generate the report reporting what was on stock on the first day of the month. So this script, what it does is that in the system we have transactions. Every time we receive goods, every time we sell goods, we record transactions. Every transaction has its part number, the stock number, number of items that we are moving out or in the stock, and exact timestamp when this happens. And based on these transactions, we can generate a report for any specific timestamp for which we want the stock numbers. But the problem is that if you have million transactions in the stock, it takes a lot of time to calculate what's the situation in the middle. First thing that we did at the beginning, which even helped us to actually run the report within a day, otherwise it wouldn't be possible in FileMaker, is that each time we create a new transaction for a good, we also store the current new numbers for the whole stock in the transaction. So we have redundant information, but at the end, when we need to generate report for the 1st of May, for example, we only need to find the last transaction for each part number that was created before 1st of May, and there we have the numbers. So this is simplified a lot in order to be able to generate the report. But when you reach some numbers like millions of records and thousands of part numbers, you still need a lot of time to just find the last transaction before specified timestamp. Why? Okay, do you know that? Why this is so complicated? The key is that when the transaction is created, the system doesn't know the timestamp for which you will be generating the report. So the timestamp is entered into the system when you want to create the report. And so the information whether this specific transaction is last one for this part number before the specified timestamp cannot be stored. It needs to be unstored calculation. So we used unstored calculation to actually indicate this transaction is the last one for this part number before the specified timestamp. I think we called it simply last, and it was 1 if it was the last one, or 0 if it wasn't. But when we searched in the millions of transactions for all those that had 1 in this field, it started at some point to take more than 6 hours to generate the report. And most of the time in these 6 hours were spent in the find request that was finding records through this unstored calculation. So we had to find a way how to speed it up, and we were able to cut it to 6 seconds or less. So I will show you what we did with the script and with the database. This is a stripped down version of our stock database, and I have only those fields that are necessary for this the purpose of this demonstration. We have each transaction has an ID number, part number of the good, stock ID where the good is located, and this is the redundant information pre-calculated. What is the current stock quantity after the transaction? This is the timestamp of the transaction, and this is the global field where we put the number for which we want to generate the stock report. And this is the unstored calculation that actually tells us whether this transaction is last for this part number on the stock. So if I scan to some older transactions, we will start seeing zeros in this field. Just a moment. Let's see here. We have a calc relationship here based on part number, stock ID, and timestamp. And it should give us the last transaction. Oh, yes. Right now I have a found set limited to 436 transactions, which are actually the ones that are last. That's why the one is everywhere. When I switch to the reverse found set, then you see that the last field contains zeros. There was one with one, but I will tell the story later. It's because this found set was already created the optimized way. So now I have, in this example file, I have 58,000 transactions, and when we did this back more than 1 year ago, this script took over 5 hours with this set of transactions, just 60,000, not millions. I ran the script last night just to have some results for you, and the yesterday's run here you can see the numbers. There is one session recorded, and the whole session spent 2 hours and 20 minutes in the database. That's because I have a new computer, which is much faster than the old one that I had 1 year ago. So this is the old script. I don't want to run it now because we don't have time for it. But I will tell you what we did to make it faster. We discovered that it's in the analyzer. When I check the session, you will see that the whole 2 hours and 20 minutes are spent between these two timestamps, constraint 2 and loop. So when I check the script, here's the constraint 2, here's the loop. So between these two script steps is what takes so long, and this is this constraint found set. And you see this just constrains the found set by the last field. So we already constrained the found set to a smaller one before running this query. And this query alone took 2 hours and 20 seconds last night. So we discovered that we need some way, and we didn't want to accept the fact that we need to use unstored calculation. We had to find a way how to find the right records without using unstored calculation. And I got a crazy idea. I knew that performing find on index field can be fast, but I also knew that even looping through 50,000 records in a loop and reading some data from them cannot take 2 hours, 5 hours at that time when I was doing that. So, however this sounds crazy, I said to my colleague, try it out. Try and measure how long it will take to loop through all the records and omit those that are not last. And to not base it on the unstored calculation, I said sort the records by the timestamp, and instead of using unstored calculation via relationship, try to decide that this is the last one by the fact that the part number has changed. So if the records are sorted by part number and timestamp, once you go to the next record and the part number changes, we return back one record, set this transaction to be the last one, and then continue with the loop. And we discovered this was really faster, but what was our surprise in FileMaker 11 was that even going through 50,000 records took just, I think it was about 2 minutes. So I discovered that FileMaker 11 got much faster in looping through records and reading them than the previous versions were. Much faster than I thought. Which reminds me, if a new FileMaker comes, some features may be slower, but also some features may get so much faster that you cannot believe it. So you should always check the same things that you tried 2 versions before, because even if they were not good 2 versions before, they may be a good way today. So this is one thing that we did. Instead of using the unstored calculation, we are looping through the records. But, you know, one thing is still a risk, and that's when you run the business for many years, the number of transactions grows. And there are going to be many transactions for goods that you will never ever sell anymore, but you have to loop through them this way. So we added one more optimization. We added a field dates on stock, and every month, the first day of the month, we find all the transactions that are last for the specific part number at that time. And for these transactions, we add the current date to this field. So, for example, this transaction for good W6F whatever was on the 1st of June 2013. This transaction was the last one for this part number on this stock. So we added the 1st of June 2013 to this field. Since this is example file that I didn't open for many months, that's why there are the missing months. Otherwise there would be also 1st of August 2012 and every other month since then. But now when I want to search for transactions that are last today or yesterday, I can very much limit the found set that I need to loop through to just the transactions that have the 1st of June 2013 in this field, and any transactions created after the 1st of June, which will be always limiting only to stock that was goods that were on stock on the 1st of June and any new transactions created within the last month. So even if the number of total number of transactions grows in the future, the script will run still about the same fast and will not become slower. And here is the result. When I run the new script, which utilizes this field and loops through the records, check how long this takes. Boom, we have the result. When I compare it exactly, I have 2 sessions, and what are the results? In this case, is it 2 seconds? I think so. I'll make it a little bit bigger. Is it 2 seconds? Inside the script? For the same thing that before happened, it took 2 hours and 20 minutes. You can count the percentage. I won't update the calculation now, but I think you will get to thousands of % as well. So this looked so marvelous that I decided to use the word marvelous to call it marvelous optimization. And I came up with the marvelous optimization formula, which explains this phenomenon. The more marvelous it appears, the less you believe it is the right way. You remember, I didn't believe the script will return the same results because it was so much faster that I thought it must be a bug in it. Then the opposite works as well. The less you believe, the more probably you are going to do it the stupid way. Because, well, if I limited myself by thinking it cannot be fast, looping through 10,000 records, I would never try it out. And I would keep doing it the bad way. So this means you have to open your mind and try even those things that look like it cannot work. But it's worth trying, especially if you know that this is the piece you need to optimize. And of course, the more stupid way you do it, the slower the script will be at the end. And so the more marvelous the optimization will look like. So it's like a loop. And I can simplify this saying that the optimization can look like a magic, especially when the original not optimized solution is very poor. And I know that there are many poor solutions out there. And that's not bad. It's natural, because things that work fine for 10 users, for 1,000 records, it wouldn't be efficient to spend too much time with them, making them ready for millions of records. But when you reach the point when they become slow, you already don't remember that you might have that you may have done it the bad way. So it means that the most efficient solution is often the less obvious one. And it comes back to the out-of-the-box thinking that's required for FileMaker development. You have to cross the borders, you have to remove your limits in your brain and think about the solutions that are not obvious. Because the not obvious solutions, that's the group of solutions that where the most efficient ones lie. So with the marvelous optimization, we reached 300,000% speed boost with the inventory report. But guess, do you know how much it helped us? Who thinks that it was a significant help? Raise your hand, please. Okay, I will tell you something. If you run the report, every night on the server side. So no one knows that. And we only need the results of the report once a month or less. So on the overall business, it had zero effect. It didn't matter at all. So I had to think why. We were so happy with the results of the optimization. Why no one came to us saying, thank you, you helped us? What was wrong with it? Then I recalled what I learned in the company, in the manufacturing company where I worked, and I recalled that I missed one critical point. I will now show you a video you might have already seen, but I think it's worth seeing even again. This is our FileMaker solution. It's a very smart solution whose main purpose is to process a very specific kind of data, high quality Czech beer. However, as our solution is getting older, it's also becoming slower. It cannot process our data as fast as we need anymore. It needs to be optimized. So have you noticed what was different in this optimization? Who knows? What? The principles are the same. In this process, we focused on the bottleneck. We discovered what the bottleneck is, and we optimized the bottleneck. And this is the key that I found, the key mistake I found in our optimization. And so I came up with the process that has just simple 4 steps. So it comes from manufacturing, where the optimization bottlenecks is the key to keeping low cost on a manufacturing process, because when you have a production line, there is always a machine that runs the all day, and even when you get faster machines for all other workspaces, the machine that's the bottleneck needs to be replaced or multiplied or whatever to make the production line optimized and make it efficient. So the process is very simple, but not necessarily easy, because it may not be obvious how to correctly identify the bottleneck. And when you correctly identify it, it may not be obvious how to optimize it. But it works like a charm. when you really focus on the bottleneck and optimize it, you get amazing results. So this is the four-step process. First, you have to measure what's happening in your solution. If you don't measure it, you cannot find the bottleneck. And the key is, as I said, bottleneck is not obvious. So if you don't measure everything, if you only measure what you think that contains the bottleneck, you may be wrong. So what we started doing with our optimizations is that we measure as much time spent in the solution as we can. And then we split it to what we can isolate and optimize, which are scripts. So we measure what time is spent in each script, but we can also measure calculations and layout drawing if it takes long. And we calculate the total time spent in each individual script for some time period. For example, if we measure 1 week, we then know that our users spent the total of 2 hours in this script and the total of 20 hours in this script. And this way we identify the bottleneck, because when we have a script that wasted maybe 100 worth of hours of our users per week, and so we know that if we optimize this single script to take only half of it, we will save 50 hours per week. That's more than 1 person for full time. That makes sense, right? That matters. So this is what we do to find the bottleneck. Then we find it. When we find the bottleneck, we optimize it. For example, to be cut to 50%. But as you saw in the Marvel's optimization, if you focus on a single script, you can optimize it by tens, thousands, or hundreds of thousands %. So you can make it run 100 times faster. And as you saw, if you were here for the Fabrices session, for example, offloading this specific script's process to the server can be the solution for you. We have found this process to be the most efficient way how to find what needs to be optimized. There are tens or maybe hundreds of ways how to do the optimization itself. And Fabrices method is one that works very well for things that can be offloaded to the server. So you can really optimize the bottleneck many times. And then the key is, which also comes from the manufacturing industry, that once you optimize the bottleneck, it's no longer the bottleneck. But if you take any system in the world, every system has its bottleneck. Every system has a point which affects the whole system's speed the most. So once you optimize the bottleneck and leave the system running, you can apply the same process again. You will find a different bottleneck and you can optimize it again and achieve another amazing results. So this is not only a very simple process to follow to achieve significant speed improvements, but this is something you can do every month or every year, whatever makes sense for you, and you can keep optimizing the system without spending too much time on it, because you don't optimize 1,000 scripts. If you have 1,000 scripts in your system and you want to optimize it once a year, you optimize 1 script a year. That's all. That's it. Many people came to me asking, we have this old system that we took over from another developer and it's crazy slow. And we are trying to convince the customer to pay us to rewrite the system from scratch because it would take fortune to optimize it. Do you know what I answer? That's not true. You only have to find the bottleneck and optimize the bottleneck. You don't have to rewrite it from scratch. Because if you optimize the bottleneck, you spend 10 times less time and can achieve the same results. So it's definitely worth trying this way. And now, how to optimize the bottleneck? As I said, every system in the world has its bottleneck. Whether the system is a FileMaker solution, whether the system is drinking beer, or whether the system is a single script in the solution. It's still a system that has a bottleneck. So once you spot the bottleneck as a single script in the system, and the script has 50 script steps, the best way to optimize the script is to find the bottleneck in the script. So you measure the script in details, you can measure every single script step, and find out which script step takes the most time. Then you have the bottleneck of the script. And guess what? How do you optimize the single script step? The same way. If it's not obvious, then you do the same thing. Find a way how to measure individual parts of what's happening in the single script step. It takes sometimes a lot of thinking, but the single script step may be a set field which is based on a custom function which is recursive. Then you need to measure the individual recursions. It may be based on 5 different functions. Then you need to measure the 5 different functions, find the bottleneck, and to replace the one that takes the most time. So this process itself is recursive. The optimization itself can be done the same way. Measure, find bottleneck, optimize, and maybe repeat. So this is what you currently have on the reference sheets that you find on the table. And I suggest, if you are serious about optimization, burn this to your brain or stick it to the wall where you work, because after 2 years of trying, I didn't try more efficient way how to optimize things. Whether it's FileMaker, whether it's software, whether it's live. It works everywhere. And because we found this system efficient, we built the product called 2for FM Bench to support this process. The product is based on multiple features. First feature we called FM Bench Detective, and it's the measurement thing. And this is available actually for free. So if you don't have it yet, you can go to the fmbench.com website, register, and you will get a download link for FM Bench Detective, which you can download, install, and start measuring your solutions. Then there is a feature called Bottleneck Finder. I didn't show you yet today, but this is the actual thing that tells you which script you spend most time in. And then there is Session Browser, which you already saw quickly, the green one, and that lets you dive deeper into the session, into what was happening in the user session, which scripts were run, how long each script took, and you can even measure every single script step or calculation or whatever and see it there and see how long it took. Sorry. So now I will show you on another example how we applied this process to our own information system. One part of the information system is a front end for the stock, and I have prepared an order for a specific good for pause on error. And now I'm going to show you how we receive goods when they come from the supplier. We log in with the dongle. to get into the system. And now we go to receive goods. It's in Czech, so sorry for no English in the user interface, but I hope it will be obvious enough. We choose the supplier from who the shipment came, and now we can receive goods. And I have ordered the specific item which is called POS X Berlin Happiness, and I ordered 1,000 pieces. Let's try to receive as many pieces as are people here in the room. So how many is that? If I'm right and I don't overlook anyone, it should be 16 including me. So let's receive 16 pieces of POS Happiness. So I'll put the part number there, which is actually usually scanned through the barcode scanner. Now we switch to quantity, enter 16, and now I click this button to actually receive the goods to stock. And when I press this button, because we have a strict rule that every single piece of whatever we receive gets its own identification sticker, we will have to actually generate 16 incoming transactions. So it will take some time. Now imagine when someone comes and brings 100 mice for computers, and we need to add them to the stock. Long time, isn't it? Just for one item and 16 pieces. Now is the time when when normal user starts thinking about the system and stops believing that it's still working. But you see, it is doing something. Anyone wants a coffee? Wow! We have just received one item. Wasn't it fast? So when we examined this process or this stock terminal, we discovered that most of the time is spent by receiving goods this way. And what I have done now is that I recorded everything here for the analyzation, and now I can find what's the bottleneck in the solution. So let's say I want to analyze today. And now I see I have one session, and in the bottleneck finder I see we actually used 94 scripts. So let's see which one is the slowest one. wow, I have a bottleneck. It's the script called new transaction. And I see that total time spent in this script was 20 seconds. Really? Only? Well, I thought it was more, but that's maybe because I'm already used to have faster systems. It might not be enough for a coffee, but you know, it's still not good. And I see there are, how many? 17 instances. So it seems that it created one transaction for every item, for every piece, which here you can see it took about 1.5 seconds for each transaction, and it created one more transaction probably for the whole process. So this is the thing that we need to optimize. How to proceed? We dive into the detail and we need to measure every single script step. I'm actually not going to measure every step, but most of them. Super secret password. New transaction. And I have already prepared the modified script. So this is the original one that we have to optimize. And here is a copy of the same script, which is different in just that it has these many instances of fmbench debug, where we record the exact time after these script steps. And the parameter here identifies which one is that, so that when we find it in the session browser later, we will know what to look for. Sorry. So I will take the contents of this modified script and I will replace it here and save it. And now we can try the same thing again. To be authentic, I will also enter 16 pieces so that we measure the same thing exactly. But we know that it wasn't enough time for a coffee, so hopefully it will be the same now. Okay, receive goods, supplier is POS Berlin, and we want Poisson error Berlin 2013 happiness. 16 pieces, receive. Now it should take about less than a minute, so let's see if it's right.
And this kind of measurement can be achieved with your detective?
Yes.
With only setting in the variables, identifying script steps?
Actually, FMBench Detective, what it does is that it uses execute SQL through a plugin and creates records in the log file here. So it creates these kinds of records. Every time it's referenced, it creates a new record here with exact timestamp. The timestamps are with microsecond precision, so you can really measure even very fast things. And it even measures its own overhead, so that you can deduct the overhead from the measured values and know what really takes time in your script. And then we have some things which you can use to further analyze the data, such as system environment information, current user, privilege sets, etc. This is very important because when you have a system which is used by 50 people and only 10 of them report that it's slow, then you definitely want to optimize it for the 10, not for the remaining 40, because the 10 do matter, they complain. And if the 10 are the people working with stock and the other 40 are working with different parts of the system, then you can take this information and analyze only data collected from the 10 users based on their privilege set or whatever. So now we have now we have recorded the exact times in the new transaction script. So let's process the data again. Okay, now we see we have 2 sessions. When I go to Bottleneck Finder, I see more instances of the new transaction. So let's choose some of the slowest ones, for example this one, and we can examine the internals of the script. Here in the session browser I can switch between absolute or relative times, so I can see what takes how long. And if you look at the numbers, you will discover that here is nearly 3/4 of a second, and here is almost 4/10 of a second. So since we know that the whole script took about 1.5 seconds, it took 1 2800. So these 2 places are where we have the bottleneck in the script. Actually, this is the one bottleneck. So let's find E in trans quantity in the script. And here it is. So we know that this single script step is taking 3/4 of a second, while other set field script steps are taking much less. So why is this happening? We set the quantity to something, and now the hard optimization begins, because it becomes much harder to find out. I have 2 ways how to do this kind of examination. First is when I go to I have to log in with a different username with the full access. And when I go to the data structure, I see that I was wrong file. Data. So this is the table, and I'm actually setting this field. Why is it taking so long? This is because there are some dependencies, and we have a lot of auto enters in this table. So I originally thought that the auto enters are calculated and evaluated when you commit the record. So my expectation was that the commit record script step will be will be the bottleneck. But then I reminded myself that the auto enters are actually applied when you exit field, so they must happen even before you commit the record, and they actually happen to be calculated after this set field, after changing the quantity. So what's my guess is all the auto enters here that are somehow dependent on quantity are affecting the speed of this set field. And I have to find the bottleneck between them. The next step for me would be either, if they are calculated, to put another measurement into calculations, and then you can find out that one of the auto enters is slower than the others. We did this. I'm not going to do this here because that will be for about half an hour to run through this whole process, but we discovered that they are about the same fast. There are, I think, 8 or 12 auto enters, but neither of them is slower than the others. So the next step we did was, well, this must be then dependent on the database structure. And since this system development started a long time ago, the structure isn't very good for large solution. This is the smaller part. If I show you the user interface file, the relationship graph there is about 10 times larger, maybe more. And we have also some old techniques there that are not very good. So the next thing is to find out what in the structure is causing the slowness. I have a technique that I use most, which is, of course, it takes some time, but you know, once you spot the bottleneck and you know exactly what you are optimizing, you know that you are effective, you are efficient, and there is nothing that makes better sense than optimizing this piece. So even if you spend half a day with this, you are more efficient than spending half a day with anything else. So the approach that I use is I take the database, make a backup copy of it, and I simply delete half of it. I randomly choose half of the whole structure and delete it. Of course, it breaks the database, it breaks the solution. But for the purpose of measurement, I can then try to run the script and see if the time that's spent in the script is less or more than half of the original time. And this way we tried, I think, 3 or 4 iterations with this system to actually find out that what's causing, I hope I'll quickly find the right relationship here. Yeah. I think it was this one. Yeah, these two relationships. What we tried is, we discovered that we have a relationship here that's based on 3 predicates. So we simplified this relationship by removing 2 of them and left only 1 remaining. This is what I said, it's deleting random half. We simply deleted these predicates, these both, which broke the solution, of course. But then we discovered that the set field was taking only about 10 milliseconds. No, 10 microseconds. So we found the bottleneck here in the relationship. And actually we spotted this single predicate to be the cause of the problem. And that's what I published some time ago in the also in the on the LinkedIn, that sometimes predicates based on comparison other than EQ may slow down relationships. And when you have something that even if it's 1 second, it's too slow, then it's worth trying to find a way how to do it without this kind of relationship. And guess what we find out? We find out that we don't need this predicate at all. We need it for a different script somewhere else, which runs once a month. But of course we can have a separate relationship for the other script and can remove the predicate from this relationship and make the critical script faster. So we just deleted this predicate, modified the other script so that it runs on a separate relationship, which I am not going to show you here. And that's the optimization. So now when I do the same thing, open the stock terminal, receive goods from Post X Berlin, again Post X Berlin happiness, 16 pieces, receive. Done. Still took some time, but not even enough to think about the coffee. And when I open the analyzer again, analyze the results, now when I look at the newest instances, I see that now instead of 1.5 seconds, the transactions are taking only 50 milliseconds. So it's half second. And I can repeat the process again and optimize further. But this was already acceptable, so this was our results. And we were done with the optimization. So by following the process, applying the same process to the details, going deeply, we were able to optimize this new transaction script within less than 2 days. And the result was very significant because it saved about 3/4 of the time spent with receiving goods on the stock terminal. When we had order with 10 items before, it could take over half an hour to process the receiving, and now it's taking less than 5 minutes.
HOnza, can I ask a
Yes.
question? Just in terms of the general approach, if you're using most other languages, you basically would say have unit testing across the board.
Mm-hmm.
change like this kind of optimization, you can basically run your unit test again, and you can be certain you've not caused any problems elsewhere in the solution. What's your sort of overall approach for how to do that kind of thing? Because you're optimizing a specific area, but how do you make sure that you don't cause knock-on effects elsewhere by optimizing this part and then making something else work?
Actually, for making sure that this relationship doesn't cause troubles when we remove the predicate, we actually used base elements to make sure we find all instances where we are dependent on this relationship table occurrence group. And that way we discovered that only 2 scripts use the table occurrence group, and we were able to isolate the other one, which we created a separate relationship for. And for collecting the results, for measuring the results, actually in the production environment, we simply keep the FM bench measurement in our system forever. We put it in 2 years ago, and now every single day the system is being used, we collect the data into the log. So whenever any user reports that they have problems with speed, we can take the log, analyze it, and start optimizing. But there is also a way in FM Bench Detective how to disable the whole system on a single place. There is a custom function called FM Bench Debug Level, and when this custom function returns 0, it does not log anything. So you can disable it and re-enable it when you need it. So this was the optimization applied on our own system, and this was the way how, by sticking to the process, we succeeded. And every time we tried optimizing something later from that time, when we followed the process, we succeeded, and we did not follow the process, we failed. And this leads me to why most people still keep failing with optimizations. First thing that unfortunately happens for our customers as well is that they never start. My estimate as the time is being now is that only about 20% of the customers who bought FM Bench are actually using it now, which is sad, and which I hope to change by running these sessions on Postner or DEF CON, and I'm also planning to do webinars to make sure that people understand how to start and why to start. The second biggest mistake, or not second biggest, but second reason why people keep failing is they don't correctly identify the bottleneck. As I said, if you measure only part of your system, and because you think that part contains the bottleneck, you may be wrong. You remember how I said that I expected the bottleneck in the script to be the commit? It was wrong. And the measurement showed me that I was wrong and showed me where the real bottleneck is. If I didn't measure the script, I wouldn't find out. And the same is with the scripts. Many times we discovered that the script that we thought was the slowest one was not slow at all. And we discovered that another script was the bottleneck. So it's really important to, this is research that can be left on a software such as FM Bench. If you have such possibility and you can reliably analyze the data you collect, it's better to do it than to guess, because you guess, it's like a lottery. You are not sure that you are working on the right piece of code, and you know that if you don't optimize the bottleneck, if you optimize anything else, like the script we optimized 300,000%, you are not going to succeed, and hear thanks from the users, because you are not going to affect their work. You have to focus on the bottleneck. So you have to optimize the right thing. The next mistake is people ignore the bottleneck. Not intentionally, but when I spotted the single set field scripts tab, the first natural reaction is when you get to an atomic operation that you don't know how to break into sub-operations, because it may be inside FileMaker. It can be something as simple as a single calculation function. You may tend to say, well, this is outside of my possibilities. I cannot optimize this, so let's optimize the next big one. That's wrong. The next big one is not the bottleneck. You are leaving the bottleneck in the system if you think this way. So the next big thing is, the next big reason for failing with optimization is if you, even after finding the bottleneck, if you leave the bottleneck in the system, then you cannot succeed. And the other one is, as I showed you, the same process can be applied in the deeper levels. And this comes from our practice. When I first let our team optimize our system using the process, I explain it. This is the process: measure, find bottleneck, optimize, and repeat. What they did is they applied fmbench, identified a single script as the bottleneck. Then they took the script, analyzed it, thought what they can optimize in the script. They optimized the script somehow, and it didn't help because they didn't apply the same process on the next level. They didn't identify the bottleneck inside the bottleneck and optimize wrong script steps. So even if you find the bottleneck, you have to apply the same process on the optimization itself, and then you succeed. So the main reason for people not starting to use FMbench Detective is they think it's hard to apply it to the whole solution. How many of you have more than 1,000 scripts in solutions? Okay, 3. How many more than 100? Most. Okay. Applying FMbench Detective to be able to measure everything means that you have to open every single script and insert a few script steps there. We did a lot of work to make it as easy as possible. We even recommend tools that can help you to use just a single keyboard shortcut to insert every script step that's needed there. And but it's still a lot of work, kind of. It took us 2 days to insert all those measurement script steps into 1,000 scripts. Do you think 2 days is too much? If you can save 1 day of work per week to the users, then spending 1 or 2 days with this optimization step is definitely worth it. But I also heard from another developer who was able to insert FMbench Detective script steps into customer solution with about 1,200 scripts in less than 7 hours. It depends on what's in the scripts. You may have long scripts, you may have short scripts, you may have a lot of interaction like custom dialogues, or you may have simple scripts that only need to be measured at the beginning and at the end. So it depends on your solution. But the average is about 1 or 2 days for 1,000 scripts, which is not bad. We are still looking for ways how to speed it up even further. But if you consider how much it takes to implement the measurement, consider how much time you have already spent with the solution until now. And decide, do this step, start measuring, because the results will be amazing. I promise. Wrong bottleneck. As I mentioned, it's important to identify the wrong bottleneck. But there is easy way to identify, to verify whether you have identified the right one. Remove it. Simplify it to nothing, to no operation. Just simply delete everything from the script and try it out. And if it becomes this fast, then you know it's the bottleneck. Of course, if you are running some subscripts, you should run them, and you should run them in the same count. But remove everything else. Remove set fields, commits, imports, whatever. And if you, of course, work on a copy of your database. But if you remove everything from the bottleneck and simplify it to no operation, it should immediately affect the speed of the system. If it does, then you have found the bottleneck. Ignoring the bottleneck. Never ever give up optimizing the bottleneck. If you give up, you're not going to succeed. Once you have identified the bottleneck, you know that this is the only piece that matters when you optimize. If you are not able to optimize it yourself, turn to your colleagues, turn to other FileMaker developers, get us to help you, get FileMaker help you, but don't give up. This is the single piece that needs to be optimized. You know that for sure, for 1000% sure, and there is no other way. And as I mentioned, the 4-step process is valid everywhere. FileMaker scripts, FileMaker calculations, relationship graph, drinking beer, going from Berlin to Prague, whatever. So whenever you need to optimize something, even if it's bottleneck that was spotted by the same process, apply the same process again. It is the most efficient way how to optimize anything that I have been able to find during the last few years. If you find a better way, tell me. I wasn't able. So, if you avoid these most common mistakes, then I'm sure you have 99% probability that you will succeed with your optimizations and you will reach much better results than replacing hardware using SSD disk, whatever. You are going to make the system several times faster, not just by 10%. And to help you with that, you can buy FMBench even now on the website. So if you are serious, if you need to optimize your solutions, take advantage of this offer, because during the next 30 days you can reach amazing results which you never saw before. We have lunchtime, so thank you and happy optimizing.